Okay, today we're going to talk about wave properties. What is a wave? Waves are up and down or a back and forth. Motion. This motion is called oscillations. And this motion carries energy. There are two types of waves. We have mechanical waves, these are waves that travel through matter. These waves are created from a speedboat, as you see them traveling out behind the boat. So waves created as a boat moves. Through the water. The energy travels from water molecule to water molecule. A second example of a mechanical wave would be a sound wave. Sound waves travel through the air. Or in other cases, gas, transferring energy from one molecule to the next. Whoa, energy. From one molecule to the next. Basically, moving sound from the source to your ear. The second type of waves we've already talked about. Electromagnetic waves. Electromagnetic waves are waves that travel through a vacuum. The spectrum runs, and it's a whole spectrum, if you recall, from radio waves on the long end to gamma rays on the short end. Waves travel at different speeds. When they are passing through different mediums. What does that mean? Sometimes waves travel through air and then they are going at a different speed if they are hitting a window. So air is a medium, glass, water. So a medium is whatever matter the air is traveling through. Sorry, the wave is traveling through. So we know this from observation, and you guys have probably seen this yourself. Mechanical waves travel faster in water than in air. And electromagnetic waves are just the opposite. They travel faster in air than in water. This is something that you can actually observe. If you were to take a pencil if you guys were to take a pencil and put it in a cup of water. Here's my cup. You would probably notice a couple of things. Here's my water. If you took your pencil and put it in the water, you would see at the surface it is different. It looks slightly to one side. It's not lined up 100% when you are looking at it from the side. I didn't leave myself enough room here. Here's my water. All right. So you might notice that the pencil is distorted. Light traveling from the air through the glass and then into the water, where it slows down. Because it slows down, it appears to not line up. This is why when you are looking at your feet, when they are in the pool, they seem like they are closer to you than they actually are. We are going to have a whole discussion about light all by itself. And we will talk more about what light is doing when it is passing from one medium to another. Waves move in two ways. The first type of wave, are called transverse waves. Transverse waves, in a transverse wave, the particles move perpendicular to the direction of travel. So this means as a wave is moving in this direction, the particles of the medium that it is moving through are displaced up and down, perpendicular to the movement. This kind of wave occurs in solids, when waves are moving through solids. The other kind of wave is called a longitudinal wave. In a longitudinal wave, particles move parallel to the direction. These kinds of waves can occur in solids, liquids, or gases. As these waves are traveling, sometimes they bounce off of a surface. When a wave is bouncing off of a surface that it hits, this is called reflection. When a wave bounces off of a surface. For example, an echo is when sound waves are reflected. And a mirror works because light waves are reflected back at you, and you can see what it is that you're looking at. Sorry, you can see your own reflection. Sometimes when waves come in contact with another media, instead of reflecting off of that, they refract. Refraction is a bending of the wave, or a slight change in the wave's direction as it travels from one media to another. This is what is happening up here with the glass and the pencil. We will talk more about refraction when we are talking specifically about how light works. The third thing that can happen when waves are traveling is absorption. Absorption. This happens when waves are traveling from one medium, they hit another medium, and they transfer the energy from the wave to matter as it passes through. The energy is transformed when it is absorbed. So light, when it is absorbed, becomes heat. For example, sometimes matter does a couple of these. Sometimes it will reflect some light, some waves, and sometimes it will absorb other waves. We will talk about this more when we are talking about light. Sometimes matter will reflect some waves. At the same time, it absorbs others. This is why we see color. The color of this pen right now is orange. That means that this absorbs all waves except orange. It reflects the orange wave which is why it is detected by our eye. That is the wave that is reflected. So I will also talk about why we see color when we are talking about light specifically. That is some information about wave properties, and I'm going to show you an example of what a transverse wave looks like.